everybody. So this is our second assignment from polymer chemistry. So let's start. The first question is the repetition of a question which we already did in assignment 1. Let's read. The number average molar mass, Mn bar, and the weight average molar mass of a polymer are obtained respectively by. So we do know that the number average molar mass, the best technique is osmometry. So it's not option C, it's not option D, it's A or B. And for weight average molar mass, the best technique is light scattering. So the correct answer to this question is option A, asked in CSIR 2012. Next question. This is a variety question. So I have already given the hint. You can add these formulas to your formula books and let's try to solve the question. So a sample experiment revealed that PVC, polyvinyl chloride, formed in the medium has number average molar mass of 13 and weight average molar mass of 16. Okay. Now you have to find the variance. Now understand that variance is equal to the square of standard deviation and you have to find the standard deviation. Okay. So this is the formula of the standard deviation which is given and we'll try to solve it with the equation which is given. Now see, this equation was not given in the question paper, but since this type of question is very rare, I had given this as your hint so that you can do it. Okay, so what is Mn? Mn is 13 into 16 by 13 minus 1 the whole raised to 1 by 2. So that is our variance. So let's write 16 divided by 13 minus 1 is 0.23076. So 13 into 0.23076 and the root of the same. Root of 0.23076, I'm calculating, into 13. So what I'm getting is standard deviation is equal to 6.244 is what I'm getting. And we need to calculate the variance. Variance is the square root of, not square root, it is the square of standard deviation which we have already found. So if you multiply, I'm getting the variance as equal to 38.96. Let's check the options. So there is option A, the closest one. That would be correct answer. Question number 2, answer A. You will be able to do this only if you know the equation of the standard deviation, which is Mn into Mw by Mn minus 1 to the power 1 by 2. So you can add that to your formula. Next question. For a polydispersed macromolecular colloid, osmometry gives. Very easy. Osmometry is a technique used to find out the number average molar mass. Correct answer is option B. Very easy. Fourth question. The fraction of groups condensed at time t. So this question was already discussed in chemical kinetics. Now those who are part of the chemical kinetics will be familiar with this question. Others, please pay attention. So the fraction of groups condensed at any time t in any stepwise condensation polymerization, which is a second order reaction is. Okay, so you have to find the fraction of groups condensed. Fraction of groups condensed. Already we said that if you have monomers A combining to form the polymer, X is the amount of monomer consumed. Correct? Sx is the amount of monomer consumed. How can we say that? Let me keep this to the side. For example, if the initial concentrations of the monomers are A0 at time t equal to 0, no polymer is formed. Now at any time t, X amount, let's say, is consumed. If X amount is consumed, X amount of the polymer will be formed. Here they have not asked the amount of monomer which is disappearing, but they have asked the fraction. They have asked the fraction. And what is fraction equal to? Fraction is the amount consumed divided by the initial amount of the monomer. Right? So this is the second order which is already given. So let's try to solve it. Using the integrated rate equation for second order kinetics, 1 by A minus 1 by A naught is equal to K into T. Now at any time T, the amount of the monomer left would be A naught minus X, correct? Minus 1 by A naught is equal to KT. Now we need X by A naught. So let's try to find X first. Let's try to find X first. So if I cross multiply, take the LCM on the left. A naught minus A naught plus X by, I'll have to take the product, right? A naught square minus X A naught is equal to KT. Now, A naught minus A naught gets cancelled. I'll write it towards the right side. And this becomes X is equal to, have to take the product, right? KT A square minus KT X A naught. Now I'll bring the X terms to the one side. So this becomes X plus KTX A naught is equal to KT A naught square it is. Now taking X common and rearranging, X is equal to KT A naught square divided by KT A naught plus 1. So this is X. We need the fraction, which is X by A naught. So dividing this by A naught will give you KT A naught divided by KT A naught plus 1. Let's check the options. KT A naught by 1 plus KT A naught. Option C is the correct answer. Option C is the correct answer. We have already done this in kinetics, so it should be easy for you. Okay. Next question. Find the probability of link in polymers where the average values of links are for A, B, C, it's given. So for this, you have to know the equation and you do know the equation. So the average values of links are 1 by 1 minus P. Okay, that is what is given. Average values are given. You have to find P. The probability of the link is what you have to find. So let's take the reciprocal so that we can find 1 by K average is equal to 1 minus P. Or if I bring P to this side, it is 1 minus 1 by K. This is how you will be finding for 3 units are given, right? A, B, and C. Isn't it correct? K average is equal to 1 by 1 minus P. If I take the reciprocal, it becomes 1 minus P. And I'll take P to this side, and this is how you find it. Okay, easy. So for A, K value is 10. So P is equal to 1 minus 1 by 10. Correct? Now 1 by 10 is 0.1. 1 minus 0.1 is 0.90. So with this, you can cut 2 options. It's not option A, it's not option B, it's C or D. Next is 50. So P is equal to 1 minus 1 by 50. Correct? What is 1 by 50? It is 0.02. 1 minus 0.02 is going to give you 0.98. So the correct option is option C, of course. Let's check the last one as well. Let's check the last one. C P is equal to 1 minus 1 by 100. 1 by 100 is going to be 0.01. 1 minus 0.01 is 0.9. So the correct option to this question is option C. Very easy. You need to know this equation, that's all. Question number 6. The condensation of a hydroxy acid produces a polyester with probability of linkage at both ends P. The mole fraction of a K-mer chain formation is. So we have learned in terms of N-mer, they have asked a K-mer. This is according to the Florey's theory. We do know that this is equal to the total probability of the linkage is equal to probability of linkage minus 1 into probability of not linkage, P to the power K minus 1 into 1 minus P. We have learned this in our class. Option C is the correct answer. Option C. Next, easy peasy question. Distribution of the molar masses in a typical polymer is always along the molecular weight. Our lowest one will be Mn, then comes Mv, then comes Mw, and then Mz. So Mz though is not asked. They have asked in terms of N, V, and W. So A has the smallest weight and the highest fraction, which corresponds to Mn. So it's not A, it's not C. Next one is going to be Mv, which means B is the correct answer. B follows this trend of molecular weight. That B. Right. Next one. The very simple question. A polydispersed sample has 10 molecules of molar mass 20,000. So let's write it down. N1 is equal to 10 of M1, 20,000 grams per mole. And 15 molecules of 10,000. So N2 is 15 and M2 is 10,000 gram per mole. The numbered average molar mass in grams per mole. So already the units are given in grams per mole. The answer they have asked is also in grams per mole. So no need of any unit conversion. Very easy. Number average molar mass is equal to sigma Ni Mi divided by sigma Ni, which is equal to 10 into 20,000 plus 15 into 10,000 divided by 10 plus 15 is 25. So let me calculate. 20,000 into 10 is 2 into 10 to the power 5. Plus you have 15 into 10,000, correct? Divided by 25. So you are getting 14,000 grams per mole. Option B. Option B, easy, asked in 2017. Next question. For a monodisperse polymer, we did this in the last assignment as well. Monodisperse polymer means PDI is equal to 1. You know what PDI is. PDI is MW divided by Mn. If that is equal to 1, then upon rearrangement, your correct option is going to be option D. Mn is going to be equal to Mw. Ninth one, option D. Next. A polymer has the following molar mass distribution. Again, number of molecules. So this is going to be N1, this is N2, this is M1, and this is M2. So they have asked the number average molecular weight of the sample. Very easy. We just did this, right? So it's going to be, should I write the equation again? Okay, let's write. Mn bar is equal to sigma Ni Mi divided by sigma Ni, which is 50 into 5,000 plus 75 into 6,000 divided by 50 plus 75 it is. So let's check. 5 into 5 is 25. 25 followed by 4 zeros plus 75 into 6,000 divided by 50 plus 75 is giving me a value of 5,600. Option B. Option B. Easy. Next question, you can mark this question as important. It's a very easy question, but then it's related with the very basics of chemistry, that's all. Okay, so the question is 5 grams per liter of a polymer. Solution is prepared with a polymer whose molar mass is 25 kilograms per mole. The osmotic pressure in atmospheres of the solution at 25 degrees Celsius is considered RTS 2500 joules per mole. So to solve this, again, whatever note is written over here was not given in the question paper. Once you excel thermodynamics, because in thermodynamics, you have to convert between pascals, liters, atmosphere, etc. So this is something that you should know. 1 liter atmosphere is equal to 101 joules. Only then you can come to this answer because they have asked the answer in atmosphere. So let's start. How to solve this? We have to start with our basic PV is equal to nRT. PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R and T the product whose value is already given. So P can be taken as the osmotic pressure, which is equal to N by VRT. You need to find N. Now, N is the number of moles. What is the given mass? Given mass is 5 grams. So 5 into 10 to the power minus 3 kilograms divided by the molar mass is 25. How to find the number of moles? It is the given mass by molar mass. Correct. So this is 25 kilograms per mole. So kilogram gets cancelled. Mole comes to the top. So this is 0.001 divided by 5 it is. Okay. So whatever it is, let that be over here. 10 to the power minus 3 by 5. I have cancelled this and I have kept 5 over there. Okay. This much of moles into, what is RT? RT is 2500 joules per mole. Okay. So again, mole and per mole gets cancelled. Whatever you get is in joules. Okay, wait. I have put just liters. Sorry, I have put just N. And this should be whole divided by 1 liters. 1 liter. Okay. So now what do I have? I have my units in joules per liter is something that I have. Correct. How did I get 1 liter? Because in the question they have given 5 grams per liter. Okay. So the value of given mass is equal to 5 grams from the question. Molar mass is 25 kilograms per mole. To calculate number of moles, you will divide given mass by molar mass and the volume given is 1 liter. So we have taken these values. Okay. Now 500 and this becomes 0.5 joules per liter. The osmotic pressure is 0.5 joules per liter. Okay. Now, again, what do we need? We need it in atmospheres. Correct? We need it in atmospheres. So how do you do that? So I'll explain. 1 liter atmosphere is equal to 101.3 joules. So we need just 1 joules. We need to convert this. Correct? Or I'll write it over here. 1 liter atmosphere. Or simply, just a second, please. So this is in joules. Okay. So if I rearrange, 1 liter atmosphere is equal to 101.3 joules. So if I want the value of liter atmosphere that corresponds to 1 joule, because I have to replace over here this joule. What do? I will divide it by 101.3, correct? That much liter atmospheres. So here also what we are going to do is 0.5. This 1 joule is replaced with 1 by 101.3 liter atmosphere. And there is again per liter which is left. Liter and per liter gets cancelled. And this value is approximately going to be equal to 0.005. You can take it as 100. So 0.5 divided by 100 is 0.005 atmospheres. That's going to be equal to option C. Option C. It's a good question related with the basics. Okay. Last question of this assignment asked in 2019. In a polymer of n monomer units, the root mean square separation between the two ends is proportional to. Very easy. The root mean square length of a polymer equation is root n into L. Correct? So root n means it is proportional to n to the power 1 by 2. Option A. Yes. So this was the intermediate level assignment questions from polymer chemistry. It was very easy. So yeah, now you're good to go. All the best.